Hi, I'm Dave from Blocky, and today I will demo how we can use our verifiable computing tools to solve a common problem with agents. Specifically, when an agent is performing a task and it needs to incorporate a new tool. Currently, the way in which this is handled is that the agent will pause and ask for human advice, but that doesn't need to happen. In our example, we have an agent that needs to collect information about a DHL package. Unfortunately, it doesn't know how to do that. But I happen to know of a Model Context Protocol server, or MCP for short, that can help. If you're unfamiliar with MCP, it's a protocol released by Anthropic that makes it easier for agents and LLMs to discover and integrate tools. So let's start off by exploring this MCP server. First, let's look at what tools are available. I wrote a bunch of small scripts into a just file to kind of help us explore this a little more easily. So we'll use the list tools, which will list all the tools that are provided by the MCP server. So we see that there are two tools available, getCode and getStatus. And we can see from the description that getStatus runs a query on the status of a DHL package. So pretty good fit for the problem that we have. But it would be a terrible idea to just use this server. It could, for example, query DHL, get your package info, tell you that the package will arrive a day later than expected, then track and steal your package. So how can you autonomously trust this integration? Well, before we can get into that, let's explore the actual outputs of these endpoints. So we'll run getStatus and wait for that to complete. And then let's page up to actually explore this response fully. Now, usually you would just expect this response to be a small JSON payload. But one of the things that we can observe is in the result, we have things like an enclave attestation, some set of keys, other things, this thing called a transitive attested function call with a whole bunch of claims and hash of the input, hash of the secrets, some output, etc. etc., etc. A whole bunch of this stuff, right? But usually we would just think of this small payload that we would get. So all of that extra metadata is going to be what allows us to actually, what allows the agent to audit and eventually verify the server's code. So while we're here, let's just take a look at the other endpoint, get code. And if you notice, go up to the top here, it's just a big old string of what seems to be random characters. So this is actually the code that our MCP server claims that it will run. So our agent is going to use this to help us decide if the server should be trusted. Now that we have explored our server, let's turn to the agent. As mentioned before, the agent would like to get the DHL information, but first must decide if it can trust the server. I'll just run the agent and talk through the steps after. Great. So now that our agent is run, let's take a look at what it actually did. So first what it needs to do is it decides that it needs to get information about a DHL package. And so it validates the MCP server for the DHL function. So it does it by first fetching the code from the MCP server, and then it compiles that code and computes the hash. It does so using the BKYC tool. This is a tool that the BKYC tool, which is a Blocky compiler tool that takes code and compiles it into WASM to be run within a verifiable computing environment. And then once it has that WASM function available, it computes the hash of it, the 64DF, etc. Cool. So then it also still has the code available to it. So what the agent does is it sends that code over to an LLM for analysis, and then takes that analysis back and uses it to make a trust decision. We can see here the report that comes back. Let's look at the full report here, which is there. Okay, great. So the LLM analysis tells us that the code matches the claim function named DHL, and it performs the expected operation, making HTTP requests to the DHL API. And overall, the trust assessment is trusted. Code appears to handle errors correctly, validate input, and securely handles API key information. It follows the best practices for error handling and data validation. Great. So then the rest of the report, the compiled hash, the LLM analysis result came back correctly, the compilation was successful, and the overall trust decision was good. Great. So now it knows that it can trust the code that the MCP server claims that it's going to run. However, the MCP server could just hand a bunch of code and then run something completely different. So this is where the next step of our system comes into play. The agent asks the MCP server to produce its result. It returns the trusted version of the DHL function output, and then the agent can validate the function output with the BKYAS tool. So this uses all of that additional metadata, such as the hashes and the attestations, to ensure that the code that has been validated and checked and was trusted in this assessment step is in fact what was run by the MCP server. Once that has occurred, the agent knows that this data is safe to use, and so we can take a look at the result, which is that in fact the parcel was delivered to a parcel locker. From there, the agent can take that information and utilize it within the context of maybe more operations, maybe finding other MCP servers that it might need to talk to, and then use this process again if it's a new MCP server that it has no idea what it runs. So thank you for taking the time to check out this demo. If you're interested and want to contact us, here's our contact information, and have a great day.